All right. So this session we would be dedicating to some other types of interesting plots, starting with the bar plots. Now, it is very important for you to understand that for a bar plot, one variable has to be of categorical nature. So that means when you are plotting a bar plot, one axis will contain the categorical data, the other axis will contain the numerical data. X-axis is the one which will contain the categorical data. Categorical data means which has options, all right, definite options are there. Like for example, if I'm taking a survey and my respondents can be divided between male and female, so male and females are two discrete categories. All right, similarly it can be male, female, children, and so on, any number of categories are possible. So the x-axis will contain the categorical data and the y-axis will contain the numerical values or the measured values corresponding to it. That's what the logic of bar plot is all about. Now, the measured values are shown in the form of rectangular bars which have certain height or certain lengths according to what values they represent in the data. So it is important to remember that whenever you have a categorical data, then line plot will not work, which is the most used plot. Everyone should understand this, that the line plots are the most used plots probably in every type of analysis. But if the data is categorical in nature, one variable is at least categorical, then you have to look for other options like bar plots, count plots, or histogram and so on. So let us imagine you did a survey of your friends to find of the type of movie they like. So let's say you have divided movie between comedy, action, romance, drama, and sci-fi, and then you have taken responses. Like so, out of all the 20 friends, four people like comedy, five people like action, six comedy, six like romance, one drama, and four sci-fi. So that's the basic raw data which is available with us. To plot a bar is very simple. We have done in the past also. We import the Matplotlib, then define the figure, subplots, then the movie type and the responses. This is the two basic raw data available with us. And plotting the bar, we need to mention the variables. And the x-axis, we need the movie type. On the y-axis, we need the responses, which is the measured value of the numerical value. Setting the y label, which is survey responses. Uh, with x labels, you can do some extra modifications. Like normally, what happens in categorical data, since we have text as a categorical data, so normally values overlap with each other. So the entire x-axis or the labels becomes too messy, so that we don't want. So normally to avoid that, what we can do, instead of horizontal alignment, we can specify vertical alignment for them. So rotation equal to 90 parameter that you can see will help you, where the x labels will become horizontal in nature rather than uh, vertical. Sorry, will become vertical in nature rather than horizontal. Okay, and then plt dot show. Simple bar plot if you want to have. Now the visualization of bar plots become more exclusive, better if you inculcate error bars into it. Now error bars are nothing. Error bars, on the top edge you will find vertical lines on every bar. I will show you practically, and the area which would be covered by the line will show you that the majority values, where the majority values are lying. Okay, so any bar which has a short error bar is considered to be more reliable. A bar with a longer error bar is considered to be less reliable, because if a error bar is long, if the length of the error bar is long, then we say that the variable that the data is too distributed, means the values are too distributed. The standard deviation is very high, in other words. Okay, so now to inculcate the error bars into the the bar plot, you need to give one more command, which is YERR. Okay, so I will take you to the Jupyter interface to showcase how it works. So this is the bar plot. Okay, now this is simple, what you have done. Okay, movie type, responses, then plotting the bar between movie type and responses, that is what we are doing, and giving the labels. If you run this, so you can see the plot. So categorical data. Now here the alignment of X labels is vertical because we have specified that 90-degree rotation. Otherwise, they might have overlapped with each other. Now there are no error bars. Error bars are the straight lines that you will find vertically on every bar like this. Okay. So now what you need to do for an error bar, you need to mention, entire data will remain same, except that you need to mention one more parameter, which is YERR equal to true. Okay. Entire data will remain same, except this additional variable. For the time being, you can forget about these extra variables that I have calculated, which is responses underscore mean or responses underscore standard deviation. The purpose is different that I will explain you later on. Okay. Okay. Let me make this thing for you. Let me copy this code. Okay. Uh, and let me here introduce the YERR equal to true. Okay. No confusions. Now, extra variable. Let me see how this turns. Now, if you see, the same bar plot has these vertical lines. Every bar is having these vertical, black lines over it. Now, this vertical line is showing that the majority responses, you know, lies between 3 and 5. So originally, our data says that 4 people like comedy. Okay. Similarly, in case of action, our majority values lie between 4 and 6. So if you see, the original data is 5. Okay, so these error bars are nothing. They show you where the majority value lies. Now, since we have taken a very small data, so these error bars might not be making much sense to you, but where the data is cool, original, you know, these error bars are of great help because they let you know that where the majority data lies or where the crux of majority value lies. Okay, so the visualization becomes more sharp. Now, what further customizations you can do here is that is the reason that I have I have made import of statics module. So I have calculated two more variables here, which is responses underscore mean and responses underscore standard deviation. Okay, so I have calculated the mean values of my responses and I have calculated the standard deviation of my responses. Okay, standard deviation means the variation. The higher the standard deviation, the more the variation. That means the lesser the reliability of the data. Simple. So now what I have done, now what you can do, again, you can plot the bar between movie type, responses, and now you can customize your error bar value. So instead of seeing that where my majority values lie, I am not interested in seeing that, okay, in which area my majority values are lying. Rather, I want to, place the standard deviation of my responses as an error bar. Now that is the reason I have calculated responses standard deviation above. Okay. So now if you run this command, you will see the error bars will differ. Okay. Now these black vertical lines are not showing you the area where the majority values lie. Rather than it is showing you the standard deviation of every category for comedy, action, and so on. Okay. Again, the logic is the shorter the error bar, the more reliable the data because that means the standard deviation is low. Low standard deviation always leads to better reliability of the data or the analysis. Okay. Similarly, if you want to see mean values, you can see mean values as an error bar also, but that will not make you any sense to you because mean value would be one only. So these bars would, the top edge of all the bars would be same. Means it will not make much sense. Let me get you. Instead of standard deviation, I am writing mean. So now see what happens. So this will not make much sense to this, right? So that is why there is no point of taking mean as error bar. It's better to see standard deviation or let it be true only. So when you mention true, it will show you that where your majority value lies. What you can do, you can instead of responses, you can take mean values here. Okay. So if you will take mean values here, again, you see now the top edge is same in all case because the data will have only one mean value, which is 4. So if you calculate the mean value of 4 plus 5 plus 6 plus 1 plus 4 divided by number of observations, the mean value would be 4. That is why the top edge is at 4. And then the standard deviation, which is, same length of vertical lines. So that is why again it will not make much sense. Okay, so you can try different things with the type of data. See, there is no one standard rule that I can give you. You have to try a lot of different things and see how you can have better visualization. Okay, fine. Then you can finally save the figures also. So these are the codes for saving the figure. Okay, you can save as PNG, as a JPG, whatever you wish. So fig.save, fig is the code. Okay, and then you can mention extra parameters like DPI is one parameter, quality is one parameter. So depends how you want to do it. Then you can set the size of the plot also, increase, decrease. In case the values are more messy, then it can be decreased as well. So it is dot set underscore size underscore inches 5 3, that means length into breadth, setting the size of the plot. So I have shown here in this code, if you see, everything is same. Okay, except that this is the for the saving the figure, and one code is for setting the size of the plot. Let me make some changes here. Let me take mean as my y variable and response as my standard deviation. Now you can see, you can variate. If you want to increase, you can make this 8. Let's say I make 8 3. You can see the size has differed. So if I want to change the height, instead of 3 I can say 4, let's say, for example. Anyhow, I can change the size of my plot as I wish. Okay, whatever level of clarity I want. Then we can plot multiple data also, multiple data as a bar plot. So for example, the same type of data you have. Now you have taken men responses also, you have taken women responses also. So now your responses are divided into different categories: the responses of the men and the responses of the women, and the movie type. So again, movie type here is the categorical data, and men responses, the women responses are the numerical values which are attached to it. So again, same funda. The only difference is you have to now pass on this code ax.bar twice. In the first case, you will plot between movie type and the men responses. In the second case, you will plot between movie type and the women responses. If there would have been a third variable, you have repeated this code and third time. Okay. Color, you can definitely mention, that's another customization that you can do. And the width of the bar. Okay, width of the bar is one parameter. You can tell the code that what the width of the bar should be, and then setting the y label and modification of the x tick labels. Okay, so if you want to do this in the this is the code for uh, plotting multiple data. So I have men and women responses. Okay, this is the code what I have. So I have placed this command twice, ax.bar. Okay, and if we run this, what happens? So these green are the between movie type and women. Okay, and this blue is showcasing the responses of the men. Fine, this is how it goes. Okay, x labels have been rotated by 90 degrees. Now if you see, the visualization might not be very clear to you, because in many cases it is not showcasing the men responses. Like for example, in case of comedy, 4 men responded that they like comedy, 8 women responded that they like comedy, but it's showing 8 only for women, not for men. The reason being, men values are lesser, so it is automatically engulfed, you know into it. That's why it is not showing it separately. So the visualization is not clear. So what we do, instead of this, we go for a stacked bar chart. Now, if you are plotting multiple data, then it is better to go for a stacked bar chart. That what happens in a stacked bar chart? The different groups are represented on the top of each other, so the visualization becomes clear. Again, same data, same commands. Okay, except a very very small change that you have to introduce. You have to give another parameter bottom. Okay, this is the extra parameter. So I will pass the ax dot bar code. I want to plot between movie type and men responses with color blue and width 0.25. Then my second code, again ax dot bar, I want to plot between movie type and women. But now since I want to draw a stacked bar chart, so I want to tell that the bottom bar would represent the men and the women values would be stacked over it. Okay, So bottom is equal to men underscore responses. The responses of the men should lie in bottom, and then the women responses are stacked over it. Color red, width is 0.25. Okay. And then setting the x and y labels. Then I have put up another additional parameter which is setting the legend values. So x dot legend. So men, women, these are the two legends I want, means representing the men responses and the women responses. Okay. So small change if you want to draw a stack, because that gives you more. This is not clear. This is not clear. Why? I have just explained you. So in a stacked bar chart, this is one additional parameter. So x dot bar, not the entire, only this portion is additional, where I have mentioned the bottom is equal to men responses, because stacking means you have to tell the code, okay, whose values should be stacked on the lower side, and and accordingly the top side would be selected. And then if you run this code, see how we get. So men values are in bottom, because here I told, I tell the code that bottom value should represent the men responses. So men responses are the bottom. So we can say that four men have preferred comedy according to the data, and 8 women. So 8 plus 4, 12. So you can see the top edge of the bar finishes at 12. So these 4 for men, and then 4 to 12. That means 4 to 12 means 8 responses for women. Okay. This is how the women responses have stacked over the men responses rather than submerging into it. Okay. Now in this case, the responses were submerged. The men responses were submerged with the women. That is why the blue color of the men responses is not getting reflected. But here no submerging is happening. Rather than the women responses have been stacked over the men responses. Okay. So this gives you better visualization, better sense of how you can look at the data, analyze the data, understand the data. Okay. So I hope it is clear. So that's for bar plots. Another very simple is box plots. Now box plots are something are more used to understand the seasonality of the data, like whether the data is varying in seasons or not, or whether it has a what type of distribution it is following, whether it would be following a normal distribution or whether it would be skewed. If it is skewed, then in what direction it is skewed, and all that stuff. So that what box plot helps you. So I will generate a random data. So I have generated four sets of data: collection 1, collection 2, collection 3, and collection 4. So I have used the code numpy, which is np.random.normal. So if you see it, it is taking three parameters, the three arguments: the mean value, the mean value, the standard deviation, and the number of values desired. So I want a data. I want total 200 values, okay, with a mean of 100 and standard deviation of 10. This is what it is telling. Similarly for collection 2, collection 3, and collection 4. The mp.random.seed, it is a very important code here for us, because if you will try this code at your home, which you should try at home, what will happen? Our plots will differ, our values will differ. Means mp.random.normal will generate some different values for me, different random values for me, and different random values for you. So to keep it same, you need to give this seed code. It can be anything in bracket. I have put up 10 here. So you should also put 10 so that our values should match. Okay. Then I have combined all these four values. In other means, I have created a list of all these four variables. So data underscore 2 is equal to plot. Now variable, I am creating a variable equal to, which is consisting of all the four collections. Then I want to plot a figure. So now I have to create an axis here. Okay. It's very important that in box plots you create an axis which is normally 0011. Okay. Now, because the reason is, see, what happens in a bar plot is it displays a summary of a data. Whatever data you are considering, it displays a total summary of data. It will which will show the minimum value of the data in the data, the first quartile, the median value, the third quartile, and the maximum. See, this is what this is how a box plot is shown, represents. It will show you the minimum value in the bottom, then the first quartile, then the median, the third quartile, and then the maximum value. Okay, this is the representation of a box plot. Once You have defined the axis. Okay. The next is to create the box plot. So ax dot box plot is what you need to do. Okay. And the data you need to give as a argument, this data which is the combination of the different collections. Okay. So if I run this here, which is the box plot, this mp dot random dot seed is very important if you want the same plot like me. Otherwise you can change, it's not important. Okay. So if I run this, you see uh, there is some error which I just need to check. I don't need this. Still error dot random. This seems good. Okay, yeah. Uh, yes. So the hashtag was little. Okay, MP is not defined. I have not made the necessary import. So let me import numpy as np. Okay. Yes. Okay, there is some more error into it. Okay, I have actually not taken this to my. Yeah, let me take this. Uh, uh, okay. Yes, now is done. Okay, so there were some things were missing. So now this is box plot. So this is how you can see it represents. Okay, the minimum value, the first quartile. This is the median, the third quartile, and these are the maximum values. These circles which you are seeing outside, these are the outliers. Outliers means values which are totally outside the scope of the data. Means some extraordinary values which are which are different. Like your majority values are between 1 to 10, and there is one value which is 18. So 18 value is totally out of the focus. It's totally different from what your data showcases. These are the outliers we say. Okay. So this is how we go for the box plots. Okay. So in the next session, we will start with the violin plots, which is another very interesting type of stuff. Till that time, thank you so much.